Okay, so this topic will be on thermometers and temperature scales. So just so you know, we will be focused on Celsius, also known as centigrade, Kelvin, and Fahrenheit. But before we look at the equations for the conversions, let's just take a look at the actual thermometers and go through, in a sense, the history of the thermometer, because I think it'll help you understand a little bit about why we have the equations we do. So if we look at Fahrenheit, which is the older of these three temperature scales, with Fahrenheit, what he did was he established that 0 was going to be the freezing point for an equal mixture of ice, water, and salt. That means, and then he set at the time the temperature for basically human body temperature to be 100. So when Fahrenheit did this, basically he wanted to set everything up. So he set the 180 degrees to be the difference between the freezing point of pure water, which turned out to be close to 32, and the boiling point of pure water, which is at 212 degrees. So why a 180-degree difference? Because it made it a lot easier for the scale, okay, to make the thermometer and have it more precise in terms of having equal tick marks. When they established, because it was kind of off from 100 for human body temperature, so that got reset to be 98.6 degrees Fahrenheit, okay? Was at 100, but then when they reset it. Now, when this happened about a couple decades later, okay, Celsius, a Swedish astronomer, came up with the Celsius thermometer, and that is much easier to actually read in tenths. So when they did that, he basically set the freezing point of pure water at 0 degrees Celsius and the boiling point of pure water at 100 degrees Celsius. Now, because the differences in the interval here on Fahrenheit and on the Celsius are different, then what we can see that when I go from 0 to 212, that's 180. That's going to be 180 degrees. Whereas if I go from 0 to 100, it's 100 degrees. So basically, for every 1.8 Fahrenheit intervals, it's equal to 1 of my Celsius intervals. And that's where this proportion comes from when we look at the formula in converting between Celsius and Fahrenheit. So basically, the Celsius thermometer sets a freezing point of water to 0 degrees Celsius. You should know that one. And 100 degrees Celsius for the boiling point of water. And that would mean that human body temperature on the average is 37 degrees Celsius. Room temperature, which we set to about 25 degrees Celsius, is basically 77 degrees Fahrenheit. Okay, so what's all this about Kelvin? Well, the Kelvin thermometer sets absolute 0. This is where there's no movement, no vibration, no energy in your system, period. Okay, it's a theoretical limit, although we've gotten really close, but it's a theoretical limit. And so what Kelvin did is he was looking at the theory, and this came after Celsius. He was looking at the theory of the relationship between temperature and the motion and kinetic energy of atoms and molecules. But you have to understand energy is always positive. So how can we have a negative temperature like we do here in Celsius? So he chose to set the absolute zero as 0 Kelvin. Okay, absolute. This is going to be hard to, I'm going to write it right here. Absolute 0. Okay, so all temperatures on the Kelvin scale will always be positive. Okay, and so what's the difference between Kelvin and Celsius? The intervals are the same. So the only difference is that 0 degrees Celsius is basically 273 Kelvin, or actually 273.15. So that leads us to the following equations. Let's get back to where to go. So where it gets us back to are the equations relating Celsius, Kelvin, and Fahrenheit. So let's do Celsius and Kelvin first. Okay, you could see that if I wanted my Kelvin scale, that would be equal to my Celsius scale plus 273.15. So 0 Kelvin is going to be equal to degrees Celsius plus 273.15. So the degrees Celsius is equal to a negative 273.15 degrees Celsius. You cannot have anything lower than negative 273.15 degrees Celsius, because that means that you're going to have negative energy. Remember, this is absolute 0. And because those intervals are 1 to 1, we don't need a conversion. We just need to shift it. And that's why all we have to do is add the 273.15. Okay, so let's take a look now between Celsius and Fahrenheit. So if I had my temperature in degrees Fahrenheit, okay, then I need to subtract 32, and this is because of that difference with the freezing point of water. Okay, and then I have to divide this whole thing by 1.8, and that should be equal to degrees Celsius. So let's check it. Now, this has to do with the difference in intervals. This has to do with where we set the freezing point of water. Okay, so if we do this, let's get my calculator. What is the temperature in degrees Celsius if the room is 77 degrees Fahrenheit? Okay, so we know that degrees Celsius is equal to 77 minus 32 divided by 1.8. Okay, so I'm going to do this in two parts. 77 minus 32, because that's subtraction. So it's going to be 45. Since this is exact as part of the equation, remember it's going to be determined by my precision or decimal placement of the temperature I'm given. So it's going to go to the ones place here. Okay, and we'll divide that by 1.8. Okay, that's two significant figures. This is exact. And you get 25 degrees Celsius. Okay, so this is considered room temperature. All right, what happens if we want to go the other way around? So suppose I say what is the temperature in degrees Fahrenheit if the weather forecast is 12 degrees Celsius. Okay, so if we know that degrees Celsius is equal to Fahrenheit minus 32 divided by 1.8, then if we manipulate the equation, we know it's 1.8 times my degrees Celsius plus 32 is going to be equal to degrees Fahrenheit. Okay, so how do I get that? I multiplied both sides by 1.8, and then I added the 32. So now we can just fill everything in. 1.8 times 12 degrees. Okay, I'm going to erase this. Okay, plus 32. And what we get, 1.8 times 12. Okay, it's 21.6 plus 32. Okay, and that should be two significant figures. I'll just double underline it here. Add my 32, and I'm going to get 53.6 degrees Fahrenheit. Okay, because that goes by least precise. And since it goes here, this is, remember, by definition exact. That's by definition exact. We get 54 degrees Fahrenheit. So it's a pretty cold day, 12 degrees Celsius. Okay, so let's do two more examples. So now you have examples on conversions between Celsius and Fahrenheit. And we talked about how to convert between Celsius and Kelvin, but let's do a couple examples of Celsius and Kelvin. So what is the temperature of a gas at in Kelvin? I should specify what I want. In Kelvin of a gas at, let's say, 96.4 degrees Celsius. Okay, remember their intervals are the same, so we're just going to be offset by 273. So Kelvin is equal to degrees Celsius plus 273.15. This is equal to 96.4 plus 273.15. And since we are adding, remember it's going to go by precision. And that means that we will stop at the tenths place. So when we do that, okay, when we do that, I'm going to be looking at this place. This is 5 or above, so I'm going to round up. So our answer will be 369.6 Kelvin. All right, let's go the other way. So what is the temperature in degrees Celsius of a liquid that is at let's say 315 degrees Kelvin. Okay, we know our formula is that Kelvin is equal to degrees Celsius plus 273.15. So you can plug in your numbers here, or we'll just subtract 273.15 in our equation first, and then plug in our numbers. 315 minus 273.15. Okay, and again, if we line it up, where do we go? Well, we go right here. Okay, so when we subtract it, it's 5, it's an 8, 1, that's a 4. Okay, we get, we're going to stop here, look after the decimal place, it's greater than 5. So we're going to round up. So it's going to be 42 degrees Celsius. Okay, let me just check my subtraction. All right, so that's how we do conversions from Celsius to Fahrenheit and Celsius to Kelvin. Now let's just do one more before we stop. And the one more is this. What is the temperature in Kelvin? In Kelvin of a solid measures 384 degrees Fahrenheit. Okay, so in this case, we don't have a direct equation between Fahrenheit and Kelvin. So what we're going to do is we're going to go from Fahrenheit to Celsius and then to Kelvin. So this is going to be a two-step process. So step 1, Fahrenheit to Celsius. So we know that degrees Celsius is equal to degrees Fahrenheit minus 32 divided by 1.8. All right. So if we put in our values here, that's equal to 384 minus 32 over 1.8. And I'm going to do this in 2 steps. It doesn't necessarily mean you have to do it 2 steps in your calculator, but the reason I'm doing 2 steps is that you can see where I'm getting my significant figures. Remember, the least precision is going to be in the ones place. So we get 352 divided by 1.8. This is exact. Remember, this is part of my equation, so it's an exact number. So exact, and then this is 3 significant figures. So our answer will be in 3 significant figures. Okay, so you get 195.56. All right, or let me just say 5. It's like 5555. That's actually what I have in my calculator. Oh, I'm missing a 5. 56. Okay, but since we want 3 significant figures, I'm going to double underline it. I'm not done with my calculations. I want to keep track of what's happening. My second step is converting, this is in degrees Celsius now, from degrees Celsius to Kelvin. So Kelvin is equal to degrees Celsius plus 273.15. Okay, so 195.55 556, okay, plus my 273.15. And where do I stop? Remember, this should have been 3 significant figures, so you're going to stop here. Why did I write this down and not round it? Because we still had some calculations to do. So I don't round until the very end, but I have to keep track of my precision here. So what we get then is, let me just see if I can add this. 6, 5, 5, 10, put a 1, 7, decimal point, 8, 16, put a 1, 468.7. Okay, 0, 5, 5, 6. Look here, go past, I round up. So my final answer will be 469 degrees Kelvin. And that's when you round at the very end before you give me your answer. Okay, so what is the temperature in Kelvin? You're going to say 469 Kelvin. Okay, and that's how to convert between our different temperatures. And in chemistry, we're going to primarily use degrees Celsius again. And especially when we talk about heat and gases, we'll be using Kelvin.